Okay, so let's do in class number 6. So we define the partial derivative of z with respect to y when you have this equation. So it would be difficult, you could try and solve this for z. So we're not going to do that, solve it for z. So we're going to use implicit differentiation to answer this. So recall that the partial derivative of z to the n with respect to y would equal n z to the n minus 1 partial z with respect to y, and also partial z to the n of x would be n z to the n minus 1 partial z with respect to x. So using a chain rule here, because we're assuming that z looks like some function of x and y. But as I said, it's going to be difficult to try and solve this in terms of x and y. Okay, so what we're going to do is take derivative on both sides with respect to y. So take derivative, let's call it star, on both sides of star with respect to x with respect to y, sorry. Okay, so we can break it into a couple of pieces here. Think of that as one function if you want to call it f1 that, and this is f2. Just going to think of one thing, which is like that is. So doing that, you have to use a product rule on this first piece. Is going to be f1 prime, f2 plus f1, f2 prime plus, we'll come back to that one. So x is a constant here, so, but the derivative of z cubed with respect to y using this, so it would be then 3z squared times partial z with respect to y plus, this is just 3y squared, and then on this side, derivative of 1 would be 0. Okay? So note now, f1 prime, the prime here means with respect to y. So my f1 is the x squared y cubed. So with respect to y, that would be equal to, so bring 3 in front, it would be 3x squared y squared. The f2 prime, so f2 prime, so f2 is the z squared. So using this guy here, it's going to be 2z partial z with respect to y. So making those substitutions then, so put this here, put this here. So doing that, we'll have, so it would be 3x squared y squared times f2. f2 is the z squared. Plus f1, so f1 is the x squared y cubed times the f2 prime, which is 2z partial z respect to y, and then we still have this stuff here. So it's right as 3 plus 3x z squared plus, times partial z respect to y plus 3y squared equals 0. Okay, now we want to isolate the, so isolate the partial z respect to y terms. Okay, so doing that, I need to move this now. Let me just write up what we have here again. So we have this. We have 3x squared, y squared, z squared plus, write this way, 2x squared, y cubed, z, partial z respect to y, plus 3x z squared, partial z respect to y, plus 3y squared equals 0. So again, isolate y terms. So isolate y terms. Partial z respect to y terms. So in particular then, let's take everything that doesn't have a partial z respect to y to other side. So doing that, this guy will stay. Y cubed z partial z respect to y, that one stays. That one stays. And the other terms go across. So this going over there will become minus x squared, y squared, z squared. Over here becomes minus. So they got this. Now we're going to factor out the partial z respect to y here and here. So let's say factor out partial z respect to y on the right hand side. So doing that, we'll get 2x squared y cubed z plus 3x z squared partial z respect to y equals this. X squared y squared z squared minus 3y squared. And lastly, we can divide both sides by this. So doing that, I'll have our partial z respect to y equals minus 3x squared y squared z squared minus 3y squared, no, that's squared, over 2x squared y cubed z plus 3x z squared. I guess you could factor the minus 3 on the top if you wanted to, but it's not going to do much. So this is our answer here. So we're done.